Hello, this is AMET 104, lecture recording week 8.1. So last time we finished the chapter 15.2, where we look at how to find average, mean, different percentiles, including median and different quartiles as well. So today I am just going to spend some time going over different examples. Not too many, but a few different examples, just so you get the gist of what you might encounter in homework problems. So let's actually start with an example. So consider a data set, and that's given as 7, -2, 5, 6, 4, 1, 9, -7, and -5. And here we have to find the average. So finding average in a small data set like this is quite simple. And we all know that to find average, you simply have to add every single one of the data points in the data set and divide by the size of the data. So let's first find the size of the data. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9. So we know that the size of the data is 9. And the size of the data is simply just the number of data points in the data set. It's just a fancier way of calling it, if it even fancy. So let's find the average. So finding average should be simple. So it's 7. So you're simply adding all these, and these negative terms are also added. So I'm just going to say plus -2, plus 5, plus 6, plus 4, plus 1, plus 9, plus -7, plus -5. Here, when you add a negative term, it's simply the same thing as just taking away 2, but I just wrote it like that just so you understand the consistency of writing, and we're simply adding everything. So since we know that the size of the data is 9, and you would simply have to divide it by 9. If you add everything on the top, it becomes 18. And simply by canceling, we can conclude that it's 2. So the average of this data set is 2. Then what about the median? How do you find the median? So in the median, we know that this is a often called the middle value, or the same thing as it's the 50th percentile. So it's essentially the same thing as finding the 50th percentile. And if you want to do that, the first step here should be rearranging the data. So let's rearrange the data. So let's say it's a sorted data. And it goes from the smallest to largest. So the smallest here is -7, -5, -2, 1, and I think the next is 4, 5, 6, 7, and 9. And once you have organized the data, make sure you count the number of points just to make sure you didn't miss anything. So we can see that 1, 2, 3, 4, 5, 6, 7, 8, 9. So we still have 9 elements in there. So we sorted it correctly. So when the data set is this small, we can simply say the middle data is just 4 here. It's a median because we can see that from this middle data, we have 4 elements that's smaller than 4. There are 4 elements that are larger than 4. So it's easy enough to find this. But let's actually put this into calculation mathematically. So we know that median is the 50th percentile. So simply you can find a locator, which is 50% of 100, multiplied by 9, which is the size of the data. And in which case it's 4.5. And we know that this is not a whole number. And hence, this 50th percentile is the 5th data because we were rounding up. And that is simply 1, 2, 3, 4, 5. It's 4. And we have confirmed that our initial choice of median is correct. So now let's say from this data set, there is another point was added. So let's say the new data set. By adding 1 more point. So -7, -2, not negative, sorry. 5, 6, 4, 1, 9, -7, -5, and 1. So here, this is a newly added value. Everything else is the same. So compared to this initial data set we were given, this new set is the same thing, except for the last value, 1. So here, let's find the average and median again. And before we do that, since we added 1, we know that the new size of the data set is 10 because it was 9 and we're adding 1 more. And the average should simply be adding everything on the top and dividing by 10. Which actually, let's just write it. So let's say 7 plus -2 plus 5 plus 6 plus 4 plus 1 plus 9 plus -7 plus -5 plus 1. And you're dividing it by 10. One thing you should note here is that remember in the previous an initial set of data, we know that the addition of the numerator was 18. You can simply add everything up again, but you can save some time by simply adding 1 more because everything else is the same. You're simply adding 1 into the numerator. So simply 18 plus 1 is 19. and by dividing it by 10, you get 1.9. So let's now find the median. So we know that the median is the 50th percentile. And the sorted data is -7, -5, -2, 1. And since there's another 1, you're simply writing another 1 here. 4, 5, 6, 7, 8, 9. So it's easy to see that the middle value is right in here. That way, if you divide it here, you have 5 on the left and 5 on the right. So we don't really have the median as the element in this set. So simply you can take the average of the two, but let's actually put that into calculation. So the 50th percentile, so we know that the locator is 50 over 100. You multiply by 10, and that is 5. So we know that this is a whole number. And what do you do when you get a whole number? Then the 50th percentile is now the 5.5, which is the 5 plus the 6 divided by 2. And in this case, the fifth value is 1, and the sixth value is 4. So plus 4 divided by 2. So ultimately it's 5 divided by 2, hence it's 2.5. So that was a very simple example. Let's do the same thing. Let's calculate the same average and the median, but now with a little more, I don't want to say complicated, but let's say a larger data than just 10 elements. Example. So let's say the table shows the result of 5, let's say a 5-point aptitude test. Given to a group of first graders. And here is what the table looks like. So you get the score and you get the frequency. And since it's a 5-point test, you can either get 0, 1, 2, 3, or 5, and 4, excuse me, or 5. And you have 6 students, 15 students, 19, 21, 11, and 8 for each score. And here we're also trying to find the average and the median. So before we do that, we know that to find either average or median, we need to know the size of the data. So we can simply find the size of the data, but how many students are there? How many score samples are there? That's simply found by adding up all the frequency. So it's 6 plus 15 plus 18 plus 21 plus 11 plus 8, and that is 80. So here, even though the problem didn't specifically note that there are 80 students in the first graders who took this test, from the table we can deduce that there are 80 students who took this test. So now let's find the average. So average, so how you find it here is, it's a different way that we did before. So remember when this was noted D1, D2, D3, and D6, and this was noted F1, F2, F3, and F6. And remember that notation here. To find the average, you're simply multiplying each data point by the frequency, because that's essentially the same thing. So here, the average should be D1 multiplied by F1 plus D2 multiplied by F2 plus all the way up to D6 multiplied by F6, and you have to divide it by the size. And when we first went over average, I think the beginning of last week, I did go over why this is essentially the same thing as simply adding up every single frequency. So if you do not remember, please go back there. I took some time to explain why this is the case. So here, D1 is 0, DF is 6, sorry, F1 is 6, D2 is 1, and you're multiplying by its frequency. It's 2 multiplied by 19, and you're doing 3 multiplied by 21, 4 multiplied by 11, and lastly 5 multiplied by 8. And you're dividing it by 80. So if you calculate the top, the numerator, you should end up with 200 divided by 80. And simply we can say that by simplifying this, we can get it's 2.5. So this implies that the average of this aptitude test of this 80 first graders is 2.5. Next, let's find the median. This is something that I didn't specifically go over during the lecture, but let's do it now. So median, we know that it's 50th percentile, and so the median is 50th percentile. And simply, we know that the locator function indicates that it's 40. And since this is a whole number, we know that the 50th percentile should be D 40.5, and that is simply D40 plus D41 divided by 2. So far, so good. Up to here, we knew how to do everything. But from the frequency table that we're given here, how do we find the D40 and D41? Because we cannot really simply count each number from the smallest to largest. So there are a few different ways to go about it. The most time-consuming way it would be you can simply lay out every single terms. So for example, you'll write 6 zeros in the beginning and you'll write 15 ones and 19 twos. You can do that and you can simply count it up to 40. But we can see that how they can be very time consuming. And now simply we only have to count up to 40, but let's say you have to count up to 200 or 400 for a very large data set, and that's not going to be very fun. So here, what you have to do is you simply add the frequencies from left to right and just count them. So we know that the last zero, since frequency is 6, the last zero will be 6. I mean, sorry, with the 6th element. And from the 7th point, it's going to be 1, all the way up to here, which is you add these two. So the last one, so last score of 1 will be the 21st element. So you're simply adding the frequency from the left. So here's how you would do it. Let me write it down. So let's first erase this. So add the frequencies from the left and find out where the 40th data point lies. And since in this case we have 6 plus 15 plus 19 equals to 40, excuse me, this would imply that we would have the score distribution that goes like ... 2, 2, 2, 3, 3, ... and this will be the 40th. And the next one will be 41st. And obviously these will be 39, 38, this is 42nd. And since we know this now, we can simply calculate it 2 plus 3 divided by 2, which gives you 2.5. So since we've done a couple of examples, a simple one and a little more like a problem that actually needs more elaboration with the average and median, let's now look at problems that have first quartile and third quartile. So let's look at an example. So consider the data set that is given as 5, -3, 8, 5, 8, 3, 8, -4, and -5. And here you have to find the first quartile and the third quartile. So before we do that, we can see that the size of the data is 9 because there are 9 data points in this data set. So it's 9. Then how do you find the quartiles? So we know that the first quartile, that is 25th percentile. So we can simply go and find the locator of 25 divided by 100 multiplied by 9, and that is 2.25. And since this is not a whole number, we can conclude that the 25th percentile is the third point in the data. And we can see that, oh, we forgot to sort the data first. Let's actually do that. Sorry about that. So the sorted data would be -5, -4, -3, 3, 5, 5, 8, 8, 8. So this is the first step. I apologize for skipping this step. And going back to the problem, so since we know the first quartile is 25th percentile, and since the locator indicates that it's the third data point, so it's 1, 2, 3, and we can conclude that it's -3. What about the third quartile? So we know that the third quartile is the 75th percentile, and the locator function should indicate that multiplied by 9, we get 6.75. This is also not a whole number, so this means that it's the 7th point. And in this case, that'll be 1, 2, 3, 4, 5, 6, 7. Should be 8. So just like how we did in the very first example that we looked at, let's suppose that there's a new additional point in the data set. So now I'm just going to, so now consider, and in this problem, which the problem is actually from the book, we're actually given the unsorted data. But just to save you some time, let's say that, let's just add on to the sorted data we have already accomplished here. So the new point that's added is now -6. And everything else is the same. And you have to find the first and the third quartile again. So to find the first quartile, since we know it's the 25th, the locator should say, now since we have added additional points, now we know that it's 10. So it'll be 25 divided by 100 multiplied by 10, and that is 2.5. And since it is not a whole number again, we can conclude that it's D3. And that should simply be -4 because that's the third. Now, what about the third quartile? So the third quartile is 75th percentile. So the locator should say it's 75 divided by 100. Multiply by 10, and that's 7.5. And since 7.5 is again not a whole number, we can conclude that it's the D8. And the 8th term in this data set is simply 8. So we can say it's 8. So this was one of the simpler examples that you could get in the homework problem. And let's actually do a little more elaborate problem like we did before. Let's work with the frequency table. So new example. And this problem says to refer to the age distribution table. That's given as this. So I want to write it. I think we need a longer table here. So the first row is the age, second is the frequency. 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, and 31. You have 8 people, 7 people, 10, 10, 8, 14, 13, 4, 4. Wait, what am I missing? Oh, okay. Sorry about that. So the problem is actually missing the 25. And that got me a little confused. So we actually have to write everything again. So we have 26, 27, 28, 29, 30, and 31. And you have 10 and 8, 14, 13, 4, 4, and 3. And that's much better. So we know how to read the frequency table by now, and you should be very proficient at that. Let's first find the first quartile. We know that the first quartile is the 25th, and I don't think I'm going to write that anymore. So let's first find now how many people are in this frequency table. So we don't know what this frequency table really represents, but we can still do the calculation. So the total number of people is not given in the problem, but you can simply find by adding in all the frequencies. So it'll be 8 plus 7. So 8 plus 7 plus 10 plus 10 plus, let me skip a few, and 4 plus 3. And we actually have 81 people. and the total number of frequencies. So since we know there are 81 people, to find the first quartile, the locator function should give you 25 divided by 100, and you're multiplying by 81. And that should give you 20.25. It's easy to see that this is not a whole number, hence that we can conclude that this is D21. And now all you have to do is count from the left like we did before. So 8, so the first 8 terms is 21s. And the next 7 is 22s. So that's a total of 15 people. From the 16th person, you have 23. They're 23 years old, and that's all the way up to 25th person. So we can see that 21st person is somewhere in this 10 people. So we can simply conclude that this is 23. What about the third quartile? The locator is 75 divided by 100 multiplied by 81. And that should be 60.75. And since it's also not a whole number, we can conclude it's D61. And 61, you have to add all these frequencies from the left and find where the 61st person lies. And they actually lie somewhere within this 13 people. And it's since it's a simple addition, I'm going to leave you to do it. And hence it's 28. Lastly, since we are finding the first quartile and third quartile, why not we find the median as well? So the median we know is the 50th percentile. So it should simply be 50 divided by 100 multiplied by 81, which is 40.5. And hence this should be D41. And we can simply see that there's 8, 15, 20, 8, 15, 25, 35. So somewhere in this 8 people, we have the median. So we can say that it's 26. So I know we've only done things like quartiles and medians, some very notable percentiles. But if you're given something that's something random, like let's say 65th percentile, which doesn't really represent anything, but it could ask you something like that. But it's all the same procedure. These have fancier names like median, first quartile, third quartile. But even if you're given some random number of percentile to find, the procedure is the same. So I don't think there is too much value in going over that when it's the same thing. So now that we have the first quartile, third quartile, and the median, before I let you go, I want to draw the box plot of this data. So as I mentioned in the previous class, you're not likely to be asked to draw a very precise box plot in any of the assignments, but I mean, at least not in the homework or the quizzes. But if you're likely to be asked which box plot represents the data most accurately, or how to interpret the box plot. So it is really important that you practice and understand how the box plot works and how to create one yourself, even though I cannot really ask you to do so right now because of the limitation of the online system. So when we're drawing box plots, we need 5 points. That's all we need. So we need 5 points. Values. And those are minimum, maximum, first quartile, third quartile, and median. Here, conveniently, we have already found the 3 of the 5, and 3 actually the harder ones of the 5. So we know that the median is 26, first quartile is 23, third quartile is 28, and minimum and maximum doesn't really need any calculation because we can simply look at the data, and the smallest point is 21 and largest is 31, so we can simply say it's 21 and 31. So let's now put that into practice. So the first step you do is that you draw a number line, and let me actually draw something longer so you can actually put more numbers in there. And say this is 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31. Let's write to 32 just in case. And I guess I drew a little too long, but oftentimes you probably won't need to write out every single numbers like this, but since the range is short, I'm just going to do it. So the first things you have to do is draw a box, since it's a box plot. And 2 left and right edges are the quartiles. So the first quartile lies right here. And the third quartile is 28, so it's right here. And we're simply going to create a box, a rectangular box, like this. And we now have a whisker that extends to the maximum and the minimum. And lastly, you indicate the location of the median by drawing a vertical line here. So we can see that this is the min, this is the first quartile, and this is the median, this is the third quartile, and lastly, this is the max. And it's really simple, that's all it is. I'm going to end the class here today, and I think that was enough practice. We didn't really go over any very advanced problems, but I don't think that's really necessary for this specific course. So next class, we are going to go over chapter 15.3, which talks about ranges and standard deviation. This could be a very confusing, it's very related to what we just done so far. And it's a very powerful tool, but it could be very confusing. It could be it's more information than what we normally go over in one section. So I'm going to try to make it as concise as possible. So yeah, thank you for joining the class for today, and I hope you have a great rest of the day.